Welcome back to Mr. Vaughn's classroom. Please take a moment, hit the subscribe button, and give this video a thumbs up if you find it helpful. Today we're in Unit 4 on functions, looking at Lesson 12 on piecewise functions. Our learning goal today is to look at functions that are defined in pieces. We have 3 learning targets today. As we go through the practice problems, please keep these things in the front of your mind, and if by the end of the lesson you don't feel comfortable making any of these statements, please drop a comment below and I'll get back to you with any help I can offer. Learning target number 1, I can make sense of a graph of a piecewise function in terms of a situation and sketch a graph of the function when the rules are given. So this means you can look at a piecewise graph and interpret the results, and it also means that if you're given the rules, you can draw that piecewise function yourself. Learning target number 2. I can make sense of the rules of a piecewise function when they are written in function notation and explain what they mean in the situation represented. So this one is saying that if you're given the rules and those rules are written using scientific notation, you understand how to apply those rules to a very specific context being given to you in an individual situation. And learning target number 3, I understand what makes a function a piecewise function. This simply means that you understand a piecewise function is distinct because it follows different rules based on what the input is, as opposed to the functions we've looked at previously, where no matter what the input was, there was always just one rule for it to follow. This one has the possibility of following different rules, and what the input is determines which of those multiple rules you're going to follow. We have 3 glossary terms today. The first one is domain. This is simply all the possible input values that you could accept. You're thinking about things like, do they need to be positive numbers? Are they allowed to be negative? Are they allowed to be 0? Can they be partial numbers? Things like that. Next, we have piecewise function. This is going to be the focus of today's lesson, and what makes them distinct is that there are different rules that this function can follow, and you're going to use the input to decide which of those rules the function will follow at that point. And lastly, we have range. Range is simply all the possible outputs that you're going to have. So, do your outputs need to be positive? Can they be negative? Can they be 0? Do they have to be whole numbers? Do they have to be a multiple of something? Can they be partial? These are things you're going to think about when you're determining what numbers are allowed to be in your range. Now we can begin the practice problems for Unit 4, Lesson 12, Piecewise Functions. Our first practice problem says a parking garage charges $5 for the first hour, $10 for up to 2 hours, and $12 for the entire day. Let G be the dollar cost of parking for T hours. Number 1 wants us to complete the table. So, the first thing we should understand is that if you don't park there at all, so 0 hours, then there's going to be 0 cost. This one just comes logically. If I don't park in the parking garage, then I don't pay any money. Next, what we see is that they charge $5 for the first hour. So any time that we spend parking that's more than 0 hours, but 1 hour or less, is going to meet this $5 criteria. And we see that right here with 1/2 hour, and we see that right here with 1 hour. So because of that, a half hour is going to be $5, and 1 hour is also going to be 5 hours. The next category they give us is $10 for up to 2 hours. So if you go over an hour, it's going to be $10 all the way up until 2 hours exactly. And we see that right here at 1 3/4 hours, or 1 hour and 45 minutes. And we see that right here at 2 hours. So both of these meet the $10 rule. And then the last rule that we're given is $12 for the entire day. So anything beyond 2 hours is going to follow the $12 rule. And we see that right here at 5 hours. So this is how we use the different rules depending on what the input is. Number 2 wants us to sketch a graph of G for time between 0 hours included up to 12 hours included. So, I need to make a quick note here for you. If a point is included, then we use a solid point. If a point is not included, we use a hollow point. So, as we look at this, our first rule is going to be right here at the top of the table. 0 hours, because we don't actually park there, is going to be $0. So we can put a solid point at the origin. Next, we have a rule that says anything over 0 hours, so as soon as you park there a single minute, all the way up to exactly 1 hour is going to be $5. So we're going to start at the 0, and we're going to go up to $5, and we're going to put a hollow circle. And this is because we're not including 0 hours here. We included 0 hours at $0. And this will go all the way up to 1 hour. And we will include the point here because exactly 1 hour will be exactly $5. And then we just draw a line to connect the hollow point to the solid point, because everything from 1 minute all the way up to exactly 1 hour will all have a $5 cost. The next rule we have is the $10 for up to 2 hours. This means I'm going to start here at 1 hour, and because that is not included in this rule, it was included in the previous rule, we're going to put a hollow circle at the $10. And this $10 price goes all the way up to 2 hours, and it includes 2 hours, so we're going to put the solid dot there. And then we draw a line to connect them, because everything from 1 hour and 1 minute all the way up to exactly 2 hours, all those time options cost exactly $10. And then the last rule that we had was here in yellow, $12 for the entire day. So I'm going to start at the 2, and I'm going to put a hollow circle at $12. And this is because the 2-hour mark is not included in the yellow rule. It was included in the green rule. And this $12 price goes for the rest of the day. And we wanted to stop it at 12 hours included. So I'm going to put a solid point at 12 hours being $12. And now I will put a solid line connecting the hollow point to the solid point, because every time option between 2 hours and 1 minute all the way up to 12 hours, all of those options are going to be the same $12 price. So this is how you graph a piecewise function. Each rule is going to have its own line segment. You use a hollow point if you are not including the point in that rule. You use a solid point if you are including that point in the rule. Number 3, is G a function of T? So remember our key wording here. A function of. We see the same thing in number 4. A function of. Anytime you see this, remember whatever comes before is your output, and whatever comes after is your input. Same thing down here on number 4. Whatever comes before those words is your output. Whatever comes after those words is your input. What we need to remember, functions have only one output for each input. So this is the definition we're using to answer number 3 and number 4. So for number 3, is g a function of t? Means let's look at all the times. Is there ever an instance of a time having more than one cost? And the answer is no. Because notice that where I have a solid point, if I go up, I will never hit another solid point, and I will never hit a line. Every time has exactly one price that goes with it. So for number 3, the answer is yes, because each time has only one cost. Number 4, is t a function of g? So now we're asking, if we say that the cost is the input, is there ever a time where a cost has more than one time? The answer here is that this is not a function, because if I go to $12, I have every time from 2 hours and 1 minute all the way up to 12. So one input, lots of outputs. Same thing here at $10. Everything from 1 hour, 1 minute, all the way to 2 hours. Same input cost, lots of different output times. So for number 4, we're going to say no, it's not a function, because some costs have more than one time. So this is how we know whether or not something is a function. It's a function only if each input has exactly one output. So if we say time is the input and cost is the output, then yes, it's a function. But if we reverse those and we say cost is the input and time is the output, that is no longer a function. If you have any questions about any part of this practice problem, please drop a comment below and I'll get back to you with any help that you might need. Practice problem 2. Is this a graph of a function? Explain your reasoning. So again, I want to go back and point out the rule. A function has only one output for each input. So one way that we test this is something we call the vertical line test. If I take a vertical line, a straight up and down line, and I move it across the graph from left to right, I should only be able to hit the graph one point at a time. If I can ever hit the graph in 2 points at the same time with a vertical line, then it is not a function. Because what that will mean is that at that input, I have more than one output. So what I want to do is run across this and look at it vertically and see, is there anywhere I can hit two or more outputs with the same input? And I see that right here. When the input is 2, the output is 1, and the output is 7. If I keep going with my vertical line, I see it happen again right here. When the input is 6, the output is 3, and it's also 7. So the answer would be no, because when the input is 2, the output is 1 and 7, and when the input is 6, the output is 3 and 7. It is not a function because each of these inputs have more than one output. And we used the vertical line test to determine this. If you have any questions about this practice problem, please put a comment below and I'll get back to you with any help you need. Our last practice problem, use the graph of function g to answer these questions. Number 1, what are the values of g of 1, g of negative 12, and g of 15? Remember, inside the parentheses is your input. So if I want g of 1, I'm going to go to where x equals 1. I have a straight line at x equals 1, and I see that I have a solid point at y equals 4. So for number 1, g of 1 equals 4. Next, we have g of negative 12. So negative 12 is my input. I'm going to go left until x is negative 12, and I have this straight line. And I see that I cross this at a line halfway between y equals negative 8 and y equals negative 12, which means this value is at y equals negative 10. So for g of negative 12, my y value is negative 10. And then the last one is g of 15. That means my x is 15. I come over here. I have my straight line. and I don't have a value because what I'm hitting is a hollow point. So what we would say is that g of 15 has no answer. Next, number 2. For what x values is g of x equal to negative 6? Remember, the number that it equals is the y value. So what we are looking for is where we have a y value of negative 6. I'm going to go down halfway between negative 4 and negative 8 to find negative 6. And I see that that happens from negative 8 included, so negative 8 less than or equal to, all the way up to negative 1, but I have a hollow point, so it's not included. So just less than negative 1. And number 3, complete the rule for g of x so that the graph represents it. So here we have the rule, but we have 2 missing outputs and we have 3 missing inputs. So first we have x from negative 15 included because it's less than or equal to negative 10 not included because it's only less than, and it has an output of negative 10, and that's this bottom line that we see. Next, from negative 10 included because it's less than or equal to, all the way to negative 8 not included because it's only less than, we look at the line and we see that this line happens when the output or the y value is negative 8. So our first missing number is negative 8. Next, we're looking for an output of negative 6, and we need the number that it begins at, but we know that it ends at negative 1, not included. And that's actually what we came up with here in number 2, where our pink highlighter is. So we said that this one begins at negative 8, included, so this negative 8 is what we're missing. The next rule happens from x is negative 1 included because it's less than or equal to, all the way to positive 1 not included because it's only less than, and we see that that line happens midway between the origin and y equals 4, so this would be y equals 2. So our missing output is 2. Next, we're looking for the line where y equals 4. And we see that right here, it begins where our blue highlighter was, and that is from positive 1 included because it has the solid point all the way up to halfway between 8 and 12, so that would be 10, and it's not included because we have the hollow point. So our missing numbers here are positive 1 included and positive 10 not included. And then we see our last rule goes from when x is 10 included up to 15 not included, and that has a value of 8. And we see that that matches what we had set up here in number 1 when we said g of 15 had no answer, and that's because the last rule says that 15 is not included. If you have any questions about any of the practice problems or concepts from Unit 4, Lesson 12, Piecewise Functions, please drop a comment below and I'll get back to you with any help that you might need. To finish up this lesson, let's review our learning targets. Number 1, I can make sense of a graph of a piecewise function in terms of a situation. Meaning, can you look at the graph and interpret the results of it based on the situation? And sketch a graph of the function when the rules are given. So can you take the rules and then know where to put solid points, hollow points, and where to draw any lines? Learning target number 2. I can make sense of the rules of a piecewise function when they are written in function notation. Meaning, can you look at the rules given to you in function notation and know exactly what they mean? Which inputs go with which rules and how those rules get you your answers? And explain what they mean in the situation represented. So not only being able to come up with the number answers, but then being able to tie those number answers back to the description or word problem that you were given in the first place. And finally, learning target number 3, I understand what makes a function a piecewise function. Do you understand that a piecewise function is when you have multiple different rules, but each input goes with one of those rules, as opposed to the entire function following one rule no matter what the input is? If you feel comfortable making all 3 of these statements, then you are exactly where you should be. If you still have any questions, please leave a comment below and I'll get back to you with any help that you might need. Again, please hit the subscribe button. That way you'll get notifications anytime I add new videos. And if you found this helpful, please give the video a thumbs up. Thank you for your time, and I look forward to seeing you in the next lesson.